Peace. What's going on? What's happening? Peace and power, elevation be to all you beautiful people out there. It's your girl Tiffany coming through here live in effect on the late night tip. All right. So on this beautiful late night, I want to talk about why do physicists study a lot into consciousness, spirituality, and philosophy. And I personally always want to know this, you know what I'm saying? Because I noticed that a lot of people that are a lot of physicists, right? Anytime I look at articles online, it's either pertaining to consciousness most of the time, or trying to find some type of correlation between consciousness and quantum physics, or they get into spirituality, or not only just spirituality, but also philosophy. Okay. And I just want to read the post that I had put up the other day. So just give me a moment. All right. I'm trying to. Okay. So let me read the post that I posted. So I said, physicist studies a lot into spirituality, consciousness, and philosophy. Could it be that they are trying to explain this phenomenon that we call nature? Just a thought and observation. So now the question is, are they trying to explain the concept of nature? Or they're trying to get some type of understanding? And so I'm going to read the comments that I received on here on my Facebook post. And I thought that these comments was very intriguing. Hold on. I'm waiting for it to load up. Okay, so let me go to my comment section on Facebook. Okay, hold on. Trying to find the comment. Trying to find the video. Nope. Okay, so I found the post. All right, so yeah, the post says physicists study a lot into spirituality, consciousness, and philosophy. Could it be that they are trying to explain this phenomenon that we call nature? And just a thought and observation. So I want to read the comments. And one comment says that that's exactly what physics is, the study of the laws of nature. That's what it is, a study of laws of nature. So I can agree with that comment. And then the person goes on to say, nature is the physical world and the laws that undergird it. Physics is a way of understanding how the world works. Okay. And I could dig it. But someone else came in with a great response. So this person came in with a good response, brother from Africa. Okay. Brother from the continent himself. I believe. Yeah, I think he's from the continent. Yeah, he's from the continent. Let me find the comment. Let me find the post. Because I just lost it again. Okay, so I'm gonna read the respond that the brother posted on here. He said, Science zealots treat it like another religion, and that's the problem. So when he was giving the response that I made about the science zealots don't pay attention to this aspect of science, meaning they don't pay. So the people that are totally scientific, like especially those who are atheists, right? They don't pay attention to those who are physics and they are studying into the concept about consciousness and spirituality and philosophy. So that's what I mean by the science zealots, right? So the guy posted on here says science, excuse me, the science zealots treat it like another religion, and that's the problem. What science is observation and experiment. No human has observed everything in reality enough to document it all. So the pursuit of science to record knowledge is noble, but a never-ending, never-ending. I guess he mean never-ending feat. Okay, yeah, but a never-ending influence by bias. Science proves to not be about facts, but about the objective interpretation of facts. All right, then he go on to say, this has put science in conflict with spirituality because objectivity to science pertains to only what can be physically observed. This has thrown phenomena like dreams, which cannot be viewed externally to individual, having them into neglect or the most inconsistent speculation of theory. Nature is a holistic system. We tend to limit it to just the earth, plants, and animals, but the entire process of sun, moon, planets, and stars influences the season on the earth. Then he goes on to say, so there are unseen forces which move through the universe that must also be considered when we speak of nature. And this is more than just matter interacting with matter, which becomes the weakness of physical science, which must be distinguished when we speak of science broadly. All right, so, and I'm going to stop right there. So I'm going to go to the part where he say that, well, let's start when he say that science zealot treat it like another religion, and that's the problem. Now, I do agree. It's nothing wrong with observing science. It's nothing wrong with admiring it. But when you put too much emphasis on science, as if science can give you the answer to everything, then that becomes very problematic. All right, because at the end of the day, it is based on facts, right? But you're not going to get all the answer from just dealing with science. So there's nothing wrong with being philosophical. Okay. So like this brother said, it's observation and experiment. Yes. So science primarily deals with observation and experiment. Okay. And again, it's nothing wrong with getting scientific information. But if you act like you're going to get all the answers just from scientists and you're not studying further into other things or how they may have their own opinion about something, then yeah, it can create problems. So then he goes on to say, no human has observed everything in reality enough to document it all. And that's very true. No human has ever went through the process of being able to observe all things. So the question becomes, when we talk about the whole Big Bang theory, how do we know for a fact that there is an actual Big Bang? How do we know? We don't really know. We don't know if the Big Bang actually exists. We don't know if there was something before the Big Bang because we wasn't around long enough to even observe that. Now we only going by what we think or what we see as now, but we don't know what was around prior to the Big Bang. So therefore, it's a lot of complexity when it comes to this. It's a lot of complexity. But then he also goes on. But he says, influenced by bias, science proved not to be about facts, but about the objective interpretation of facts. Okay, that's pretty deep. Science proves to be not about facts. So again, yes, you have those in the scientific field that can use their confirmation bias because they don't know exactly if it's based on facts. So they're going to have their own bias that's going to fit their narrative. Now, also with science, there's going to always be information that has to be upgraded. That's going to have to be corrected because what you may have thought that it was at one point in time turned out to be something totally different. And there's always somebody that's going to come in and challenge those consensus. And that's one of the reasons why I like physics, because especially those that are in the physics field, they take the time out to actually and study beyond just their own perception. They actually question things, like they actually question the legitimacy of consciousness. Is there a such thing as a consciousness? Is there a such thing as a soul? Is there a such thing as spirit? Does these things really exist in our world? They actually take the time out to actually sit down and have a conversation with people that's into the spiritual system, right? So physics and anthropology have to be one of my main two subjects I love, because you take the time out, you ask questions, you deal with, you can not only just deal with from a philosophical standpoint, but also deal with things from a cultural standpoint. So, and that's the whole element of physics, like understanding not just a philosophy behind it, but being able to understand cultural interpretation and not just be limited to one particular idea. Let's see. So I'm going to skip down where the person said that nature is a holistic system. Well, nature is not just a holistic system, but it's also the most powerful system. Because it's like no matter what we do as human, no matter how many things that we invent, no matter how many technology we come out with, nature is going to have the final say so. Nature is the most powerful force there is. So it's not just a holistic system, it's also a powerful system. It's very powerful. That's the key. So nature oh, hold on. Shit. Okay, my bad. My bad. Sorry about that. But yeah, nature is the most powerful system that we have. So it's not a force to be reckoned with. So it's not just only holistic, it's a force that cannot be reckoned with. It cannot be reckoned with at all. So I agree. As a matter of fact, let me show you guys the comments. That's a lot easier. That's a lot easier. Okay. Okay, if you guys can see the comment section. All right. Then this person also agreeing to the chat. Shout out to the chat. Peace to the chat. So this person also put down, we tend to limit it to just Earth, plants, and animals, but the entire process of sun, moon, stars, and planets influences the season on the Earth. That's factual. I agree. And so then what it says, there is unseen forces which move through the universe that must also be considered when we speak of nature. Now, the unseen forces that he's talking about is what we call the subatomic particles, the particles that we cannot see with the naked eye, but we know they is there. Is there. We can't see them because they're subatomic particles, right? They're below the atoms. So they there, but we're not able to observe them. But we know that there's particles that's moving around in this universe that's making the universe whole and give it some type of foundation. So, and we also got to realize that we are made of particles as well. Okay. All right. So also I want to go where hold on. Okay. So I want to also go where it says and this is more than just matter interacting with matter, which becomes the weakness of physical science, which must be distinguished when we speak of science broadly. Absolutely. Before physical science, there was natural science, before physical science, there was natural science, which under which topics like astrology were taken seriously and identified the influence of cosmic bodies in the earth. The calendar, the calendar is relic, but no one seems to notice we still follow astrology with astrologic, even if physical science claim it could not find evidence in relationship of matters to prove its validity or truth. Okay, so yes, we do follow some form of astrology, but today astrology is no longer really needed because you have astronomy and you have astrophysics. So astrophysics and astronomy, they both can give better explanation about the universe and its physical property, right? As far as the stars and the sun is concerned, these things can give better explanation than astrology. But yes, astronomy came out of the school of astrology, so there is a astrological concept that's carried on into astronomy, right? But astronomy give better explanation because now you have mathematics that's involved in it. All right. So it says, by no means is science a final authority, though it is a very valuable assistant in understanding what is the current level of mainstream thought. For example, medical science say COVID-19 has no cure. Yet 85% of people who get infected recover from it by managing the symptoms. Okay, I'm back. I'm back. So let me go back to what I was reading. So it says the count, no. Okay, so it says by no means is science a physical authority or is a final authority, though it is a very valuable assistant in understanding what is the current level of mainstream thought. For example, medical science say COVID-19 has no cure, yet 85% of people who get infected recover from it by managing the symptoms at home using a range of herbs, including ginger, garlic, lemons, and limes. This situation clearly exposes the flaws in following physical science advocate claims and not paying attention to the law of natural science. Okay, so this is where my disagreement comes in regarding to the COVID-19. All right, so for one, of course, there's really no cure for viruses. So what's going to happen is with viruses, they don't die out, they mutate. They mutate. That's all they do. They don't die out. So, of course, there is no cure for viruses. However, you can relieve yourself from the symptoms. You can recover from it. There's a concept of remission. So, just because just because you feel better doesn't mean that you don't have the virus in you. It's just like when you have a cold. Now, only thing you can do is relieve the symptom of the cold, but you still got the virus in you. Okay, that virus still stay within you. It's just going to mutate over time. So you didn't get rid of the COVID-19. You just got rid of the symptoms because that virus is still there. So, of course, at this point, there's no cure for it. I mean, yeah, you can get vaccine and whatnot, but that doesn't mean that it's going to cure. The vaccine can only do enough to where it's going to help build a pathogen in your body to be able to fight it off. But other than that, it's not going to cure it. All right. So he said that this situation clearly exposes the flaws in following physical science, advocates claims and not paying attention to the laws of natural science that the former interprets at the time falsely to support a biased theory. Let me not ramble. Okay. So for the most part, I agree with the individual statement. I thought it was very interesting. But then when he got down to the concept about the COVID-19, that goes to show that we don't really understand how viruses work. And again, viruses don't die. They just mutate. That's all they do. All right. But I want to go ahead and sum this video up to talk about why it's important to study spirituality and consciousness, because at the end of the day, you deal with interpretation of how to adapt with the law of nature. Now, let's look at what the law of nature is real fast. Or let's look at the job of a physicist. Okay, so all right, a physicist is a scientist who specializes in the field of physics, which encompasses the interaction of matter and energy at all length and time scales in physical universe. Physicists generally are interested in the root or ultimate causes of a phenomenon and usually frame their understanding in mathematical terms. Physicists work across a wide range of research fields, right, spanning all length scales from subatomic and particle physics through biological physics to cosmological length scales encompasses the universe as a whole. The field generally includes two types of physics: experimental physics, who specialize in the observation of natural phenomena and the analysis of experiments, and theoretical physics, who specialize in mathematical modeling of physical systems to rationalize, explain, predict natural phenomena. Physicists can apply their knowledge towards solving practical problems or to developing new technology, also known as applied physics or engineering physics. Okay. All right. So you got two different type of physics, right? You got the experimental physics, who specialize in the observation of natural phenomena, and then you got theoretical physics, who specialize in mathematical modeling of physical systems. So now the people that mainly study a lot into this consciousness stuff and spirituality would be more like theoretical physicists, because what they try to do is bring about rationalization and explanation and bring some type of prediction to the natural phenomena. Okay. Okay, so that's the whole thing. Again, as the brother mentioned previously on my post about the laws of nature. Now let's look at laws of nature. All right, so as a matter of fact, hold on. Let me do it this way. All right, so getting into this, it says laws of nature, right? Laws of nature are to be distinguished both from scientific law and from natural laws. Neither natural laws as invoked in legal or ethical theories nor scientific law, which some researchers consider to be scientists attempt to state or approximate the law of nature, will be discussed in this article. All right. So they says laws of nature versus laws of science. In 1959, at the annual meeting of the American Association for the Advancement of Science, Michael Scruven read a paper that implicitly distinguished between laws of nature and laws of science. Laws of science, what he at that time called physical laws, with few exceptions, are inaccurate and are at best approximation of truth and are of limited range of application. The thing has since been picked up and advanced by Nancy Cartwright. If scientific laws are inaccurate, then presumably there must be other laws, doubtless more complex, which are accurate, which are not approximation to the truth, but are literally true. All right. And it says, and then going down, it says it is a explication of these latter laws, the laws of nature, that is the topic of this article. It does not examine the approximate truth of science. Thus, to cite just one, the controversy over whether scientific law or merely instrument lies outside the topic of this article. All right, so here is under laws of nature, right? Are factual truth, not logical ones. The boiling point of sulfur is 444.6 Celsius. Express a factual truth. Every number has a double expresses a logical truth. All right. And then it goes on to say, are true for every time in every place in the universe. There are no laws of nature that hold just for the planet Earth or the Andromeda galaxy for that matter, nor are there any that hold just for the 18th century or just for the Mesozoic era. Contain no proper names. Laws of nature may contain general concepts such as mass, color, amplitude, capital, diabetes, return of investment, but may not contain such terms as the Fraser River, the planet Earth, $59.22, June 18th of 1935, IBM, etc. And then the fourth one says, are universal or statistical claims, and all pure copper conducts electricity expresses a law of nature. But stars exist, although truth does not express a law of nature. It is neither a universal nor a statistical claim. Right? And then it goes on to say, are conditional claims not categorical ones? Categorical claims, which are equivalent to conditional claims, there are no perpetual motion machines of the first kind, which is equivalent to, if anything is a perpetual motion machine, then it is not the first kind. All right. So let's look at the different category of laws of nature. So here is the four fundamental laws of nature. All right, so the first one is the gravitational force between Earth and the sun is ascribed by the exchange of these gravitation between gravitons between the particles that make up these two bodies. Although virtual, they have a significant effect. The Earth orbiting around the sun. Real gravitons make up what classical physics call gravitational waves, which are too weak and very difficult to detect that they have yet been observed. All right. And then the second one is electromagnetic forces. They are much stronger than gravitational forces. In fact, the electromagnetic force between two electrons is about a million times bigger than the gravitational force. However, there are two kinds of electric charge, positive and negative. The Similarly charged particles repel, and in contrast, differently charged one attracts. So a large body such as Earth or Sun nearly contains the same amount of positive and negative charges, which cancel out, and a very little net electromagnetic force is produced. However, on a small scale, a microscopic scale, to be more precise, electromagnetic forces dominate. All right, so that's the second one. And then the third one is the weak nuclear force, which is responsible for deadly stuff like radioactivity, and which acts on all matter particles, right? So, and then the weak nuclear force was not well understood until 1976, when Ada Salam at Imperial and Steve Weinberg at Harvard both proposed theories that unified this interaction with the electromagnetic force, the same as Maxwell unified electricity and magnetism about 100 years earlier. Okay. Then it goes on to say they suggested that in addition to the photon, there were other spin particles known as massive vector bosons that carried the weak force. Each had a mass about 100 GeV. GeV stand for giga electron volts, or 1,000 million electron volts. The Weinberg-Salam theory exhibit a property known as spontaneous symmetry breaking. All right, so it said this means that all these particles appear to be the same at low energies, only in different states. However, at higher energies, all these particles behave the same. All right, and then the fourth one is the strong nuclear force, which holds the quarks together in a proton or neutron, and holds the protons and neutrons together in the nucleus of an atom. All right, so as you can see, these are the 4 laws of nature. Okay, 4 laws of nature. But technically speaking, there is no laws of nature. It's just nature in itself and how nature operates. That's all it is. So technically, there's not a law per se, like obligation wise. It's just how nature operates. And it's just the scientists' way of understanding how nature move at a force. That's all it is. All right. But yes, anyways, sometimes it's okay for somebody that's in a scientific field to actually study cultural interpretation and spirituality and philosophy, because philosophy only deals with the values of things, whereas science just deals with the facts. So you may not find the facts in science, but you might find the value from a philosophical standpoint. And I guess for a lot of physicists, they looking at the value of people, of the interpretation of what we call the phenomena, or the existence of nature. So that's where they're looking at the value of how various philosophies go about explaining the natural phenomena. And again, the question becomes, with consciousness, does consciousness really exist? What is consciousness? Is that only a subjective thing? Where is the objective to prove it? How do we know that consciousness exists? What does it mean to have a soul? How do we know that a soul exists? What does it mean to have a spirit? How do we know that a spirit exists? So they take it a step further, especially those who are theoretical physics. They're going to take it a step further because they're trying to really find a correlation. Those who are in the quantum physics field, they're trying to find the correlation. All right. But I think you guys should also check out this article right here from eon.com or eon.co. It's called Philosopher's Zombie. The infamous thought experiment, flawed as it is, does demonstrate one thing: physics alone can't explain consciousness. I mean, and again, I have to agree that physics alone can't really explain consciousness. So that's why you would have to get with somebody that's very philosophical, or somebody that's into, somebody that's a philosopher, or somebody that's into neuroscience or something like that, to be able to actually explain. That's why someone like Sir Roger Penrose is a physicist. Okay, so he has connected with So Sir Roger Penrose connected with Dr. Stuart Hammeroff. So Dr. Stuart Hammeroff is an anesthesiologist and also a psychologist. So they both trying to find connection into, like, well, how does quantum physics brings about the correlation to one's consciousness? So Dr. Roger Penrose could not study it on his own as a physicist. He could come up with his own interpretation. He can just come up with saying, well, maybe it's this, maybe it's that. But he wouldn't be able to come up with an answer. He wouldn't even be able to draw a conclusion. So it was best for him to study with someone like Dr. Stuart Hammeroff, because at least Dr. Stuart, being that he's an anesthesiologist and into neuroscience, and also deals with psychology in the sense that he'll be able to come up with a better explanation and come up with a better hypothesis. So yeah. So yeah, a lot of time when physicists have questions about things that cannot be answered, right? Or things that are, still a mystery, they try to formulate their own conclusion. So, and the way for them to do it is be able to link up with those who are not in the same field of study as them, but those who are dealing with things from a spiritual standpoint, from an anthropological standpoint, from those who are into neuroscience, so they can be able to draw a better conclusion, have better interpretation, and come up with a better hypothesis to validate their claims and arguments. And this is very common among scientists. They always going to have their own hypothesis, regardless. They're going to always have their own discussion. They're going to always have their own conclusion. They're not going to always agree with each other. So scientists even let you know they don't even know. They don't even have the answers. Everything in the universe cannot be explained. Everything in nature cannot be explained. So some things they're not going to be able to tell us. And some things are going to be left unsaid. But anyway, that's all I have for this evening. All right. Yeah, that's all I have for this evening. So, or on this late night. But other than that, I hope you guys have a good one. I may have to redo this video because this wasn't my best. But I'm out. And I'll talk to you guys later. All right. Peace.